All right, the directions say find the solution set. We're going to be doing one-step inequalities. Once you've found the solution set, we're going to graph on a number line. So I've got the cheat sheet right behind this paper, and we're going to reference every single time we do this. All right, so number one, read this to me. Okay, 5x is greater than or equal to 20. If this was an equal sign problem, if this was an equation, how would I solve for x? I'm going to divide both sides of the equation. Sorry about that. Divide both sides of the equation by 5. So now I've divided both sides. Let me just make sure. So if I divide both sides of the equation by 5, did I divide both sides by a positive or divide both sides by a negative? I divided both sides by a positive, therefore the sign stays the same. So therefore x is still greater than or equal to 4. So that gets boxed. And now I'm going to draw a horizontal number line where 0 is in the middle. Where is 4 compared to 0? To the left or to the right of 0? To the right. So I'm going to put 4 to the right. I'm going to circle the 4, the endpoint. And remember, x is allowed to be all numbers greater than or equal to 4. So all numbers greater than 4 are 5, 6, 7, 8, and so on and so forth, a million. And at the end of the number line, I put a big fat arrow. But it says greater than or equal to. So what numbers are allowed to be? Is 4 invited to the birthday party or not invited to the solution set birthday party? It's invited. So x is allowed to be 4 or more. And this statement is true because if x was 4, 5 times 4 is in fact 20. 20 is greater than or equal to 20. So that is true. 5 times 5 is 25, greater than or equal to 20. 5 times 3 is 15. 15 is not greater than or equal to 20. So anything that's shaded is true. All right, let's take a look at number 3. 3x is, remember, this symbol is less than 21. So 3x is less than 21. If this was an equation, how would I solve for x? 3x equals 21. Pretend. How would I solve for x? I would need to divide both sides of the problem by 3. And did I divide both sides by a positive or both sides by a negative? By a positive, so the sign stays the same. So therefore, we've got x, which is still less than 21 divided by 3 is 7. So as long as x is less than 7, this statement is true. Let's go with, let's draw the number line, 0 in the middle. Where is 7 compared to 0? To the left or to the right? To the right. So let's just say I go here. I care about the endpoint 7. And where do I shade if x is allowed to be all numbers less than 7? I shade to the left of 7. And I reach the end of the number line, so I put a big fat arrow. Any number that's in this shaded region is true. Okay. Number 3, 1/3 of x is greater than 4. Well, in order to get x isolated, I need to multiply both sides of this inequality by 3 over 1. So I multiply the left side by 3 over 1, that cancels out. And if I multiply the right part by 3, that cancels out, leaving me with x is greater than 12. Because if I multiply both sides of the equation by a positive number, the sign stays the same. So x is greater than 12. If I put 0 in the middle, let's say I put 12 way over here, all numbers bigger than 12 go to the left or to the right of 12? Goes to the right. And is 12 invited to the solution set birthday party? No, it says x is greater than 12, not greater than or equal to. So even though 12 divided by 3 is equal to 4, that's not what this requirement is asking. It wants to be greater than 4. So 13 divided by 3, whatever that decimal is bigger than 4. So that is true. So let me make that a little bit neater. So there's my endpoint, and then I shade to the right. 1/9 of x is less than or equal to 2. What do I do to solve for x in problem number 4? Well, in order to undo that layer on x, I'm going to multiply both sides of the equation by 9. Specifically on the left, I want to cancel out that fraction to get me 1x. So if I multiply the left and the right by 9, the sign doesn't flip because I multiply both sides by a positive number. So x is less than or equal to 2 times 9, which is positive 18. Now that I've got 0 in the middle, and let's say 18 is way over here, which numbers are less than 18? To the left or to the right? To the left. So let's say I circle the endpoint, and I want to color the entire number line for all numbers less than or equal to 18. I've reached the end of the number line, so I put a big fat arrow. There we go. Anything that's shaded makes a true statement. Is 18 itself invited to the birthday party? Yeah, it says less than or equal to, so there we go. That makes my life so much easier. That bar tells me to fill in that endpoint. All right, now we're getting a little bit confusing, but we're not going to be so scared. Let's take a look at number 5. 4x is less than negative 36. So how do I solve for x in this problem? I'm going to divide both sides by 4. But remember, when I do this work, I'm going to look at my table. Did I divide both sides by a positive or divide both sides by a negative? Right, the right part is negative, but I didn't apply divide both sides by a negative. I applied divide both sides by a positive. So that sign technically has to stay the same. So that cancels out, leaving me with x is still less than negative 36 divided by 4, which is negative 9. And if I put 0 in the middle, let's say I put negative 9 on the left, all numbers less than negative 9 have this endpoint. Less than negative 9 means I shade to the left. So I'm talking about numbers like negative 10, negative 12, negative 14, negative 172. But is negative 9 itself invited to the solution set birthday party? No. So let's say I plug in a number that's barely to the left of negative 9. Let's go with negative 10. 4 times negative 10 is negative 40, and negative 40 is technically less than negative 36. Whereas if I plug in negative 8, 4 times negative 8 is less than negative 36. That'd be negative 32 is less than negative 36. At x equals negative 8, negative 32 is not less than negative 36. So therefore, that would be false. Anything that's shaded is technically true. All right, let's take a look at number 6. 13x is greater than or equal to negative 26. What would I need to do to solve for x here? Yeah, in order to solve for x, I would love to divide both sides of the equation by 13. But remember, I don't care that the output is negative. I care that I applied divide both sides by a positive number. So we're good. So x is greater than or equal to, still, negative 26 divided by positive 13, that is negative 2. So I'm going to box that part. There's 0 in the middle. There's negative 2 to the left. And remember, x is legally allowed to be all numbers bigger than negative 2 and including negative 2. So that means all numbers shaded to the right. And so I put a big fat arrow at the end of the number line. And is negative 2 itself invited to the birthday party? Yes, so we color it in. Make that endpoint obvious. I should have made my dot a little bit bigger. I'm a fat dot person, as my 11th grade teacher once told me. Okay. Number 7. Negative 7x is less than 42. What would I need to do to solve this problem for x? I'm going to divide both sides of the inequality by negative 7. But I'm going to look at my table, because I got x isolated. What did I do to both sides? Did I divide both sides by a positive or divide both sides by a negative? Well, I divided both sides of the inequality by a negative, so the sign is no longer true as it is. So the sign needs to flip. So therefore, I like to make a little note to myself and say, hey, the sign needs to flip because I divide by negative. So if I divide both sides by a negative number, x is now greater than negative 6. So now, as I get my number line, I put 0 in the middle. Where is negative 6 compared to 0? It's on the left. So I put a negative 6 right there. I circle the endpoint. And what numbers are bigger than negative 6? To the left or to the right? To the right. Negative 5, negative 4, negative 3, 0, 27, and so on and so forth. And at the end of the number line, I put a big fat arrow to go to infinity and beyond. But is negative 6 itself invited to the birthday party? Nah. All right. Negative 5x is greater than or equal to 45. So how do I solve for x for this problem? I'm going to divide both sides of the inequality by negative 5. And I'm going to check what did I do on both sides. Well, I divided both sides of the inequality by a negative number, so the sign needs to flip. So now I've got x, but this inequality symbol needs to become a less than or equal to sign now. There we go. Now we're in business. 45 divided by negative 5, that becomes negative 9. And I'm very, very happy because this divide by negative means the sign has to flip. So now I make a little number line. I put 0 in the middle. Where is negative 9? To the left or to the right of 0? Yeah, negative numbers go to the left, so I'm going to put negative 9 over here. I circle my endpoint. What does less than mean? To the left or to the right of negative 9? To the left. And finally, is negative 9 itself invited to my birthday party? Yes, the sign flips, and the less than or equal to still means equal to as well. So x is legally allowed to be any number in this shaded region. Okay. Number 9. Negative 8x is greater than negative 56. What would I need to do to solve for x? Bless. Excuse me. Negative 8x is greater than negative 56. So what I would need to do is divide both sides of the inequality by negative 8. Now, I've got a negative coefficient and I've got a negative output. I still divided both sides of the inequality by a negative, so the sign still technically needs to flip. Again, it's what I do on both sides that makes an impact. So now that the x is finally isolated, negative divided by negative is a positive. So x is legally allowed to be any number, as long as it is less than 7. So if I pull out x is less than 7, I put 0 in the middle, 7 to the right. My endpoint is 7. And all numbers less than 7 go to the left with a big fat arrow. Okay. Is 7 itself invited to the birthday party? No, it says x is legally allowed to be less than 7, not less than or equal to. So 6.999999992 is legal, but not 7 itself. All right, let's go with this one. Negative 2x is less than or equal to negative 30. So what I can do is I can rewrite this problem. Negative 2x is less than or equal to negative 30. So I'm going to divide both sides of the inequality by negative 2. Once again, I divided by a negative, so the sign itself is no longer true. I need to switch it to become greater than or equal to. So x is greater than or equal to positive 15. And therefore, if I plug in any real number that is greater than or equal to 15, let's go with 15 to the right, circle, shade to the right because it's greater than, right, big fat arrow. Is 15 itself invited to the birthday party? Yes. Okay, so I'm going to cut it off right around there. Hopefully this helped out a lot. We'll do more solve one-step inequalities in the next video. Have a great day.